Good morning, my friends. Just when you thought we were done, we're back. We are going to start the 6th grade book, so course 2. Now, as you know, the beginning of each book is a lot of review. So I'm going to jump around and pick out the lessons that I think we need to review the most. So we're not going to really go in order, and that's okay. Just look for my updates on Teams. Today, we're going to start with lesson 2. It's a lot of vocabulary, so you need to have a notebook and a pencil. Go get one. Okay, course 2, lesson 2, properties of operations. So we're going to be looking at the properties of addition and the properties of multiplication and what each of those means. So let's get started with the inverse operations. What does that mean? If I asked you what the inverse operation of addition was, you would say, right, subtraction. So inverse operations are the opposite, or undoing what we just did. If we had positive 3, the inverse would be negative 3, because together that would make 0. Okay. So now getting into properties. This is only a few. I actually have a few more vocab words. I just couldn't fit them all on the board. So we're going to get started with these 3 and then add as we go. The first property is the commutative property. Commutative means I can rotate the numbers and still get the same answer. So for example, 3 plus 2 is the same thing as 2 plus 3. The placement of the digits doesn't matter. My answer will still be 5. You might see it written as so. A plus B equals B plus A. Next, we have the identity property. And the identity property is when 0 is added to a number, the value stays the same. So, if we were to do 3 plus 0, my sum is the same as my beginning value. So the identity property means the identity of the first value is not changing. The identity will stay the same. We might see it written as A plus 0 equals A. Okay, so we just discussed properties of addition, but now let's discuss properties of multiplication. Commutative. Let's think back to what commutative meant in the last definition. So commutative in the last definition meant the order of the numbers didn't matter. The sum would still be the same. Well, let's see if that would be true for multiplication. If I switch the order of numbers, 5 times 4, is that still equal to 4 times 5? Yes. So I could say that the commutative property of multiplication is similar to that of addition, that the order of digits does not matter, the product will stay the same. Now the identity property is not quite the same as addition. The identity property of addition states that adding a number with 0 keeps the sum equivalent to the original value. If I multiply a number by 0, is the product the same as where you started? No, your product would change to 0. So what do we multiply to keep a digit or a value the same. We would multiply by 1. So the identity property of multiplication states that multiplying any value times 1 will keep the same product. So we could do A times 1 equals A. So for our last example, the property of 0. This states that when you multiply a number by 0, the product is always 0. So 5 times 5 times 0 equals 0. We could say A times 0 equals 0. Okay, we're not quite there yet. We have a few more. The associative property. So the associative property for addition states that the grouping of addends does not change the sum. So for example, if I had 2 plus 3 plus 4, and group them differently, would I get the same answer? Well, on the left, 2 plus 3 is 5, and 5 plus 4 is 9, 3 plus 4 is 7, and 2 plus 7 is 9. So the associative property states, again, that the grouping of which you solve does not change the outcome. Now, the associative property for multiplication also states that the grouping of which you multiply does not change the outcome. So let's try that with the same numbers, but this time for multiplication. Okay, 2 times 3 is 6, times 4, 24, 2 times 12, and it worked. The order of which I solved did not change my outcome. Okay, now let's explore subtraction and division, because all of these properties only had to do with addition and multiplication. So let's review. Commutative meant what? Commutative means I can switch the order of numbers. For example, 12 plus 5 equals 17. 5 plus 12 also equals 17. But what if I did that with subtraction? 12 minus 5 equals 7. Can I flip those digits and get the same value? No, I cannot. So the commutative property does not work for subtraction. What about the associative property? What is the associative property? The associative property is grouping the numbers. So if I did 12 plus 5 plus 7, and I grouped those two first, 17 plus 7, 24, and then if I grouped 5 and 7 first, 5 plus 7 is 12, plus 12 is 24. So let's try that with subtraction. We need some more space. And I'm going to change the numbers up. So what if we did 15 plus 15 minus 5 minus 2. And I group these together. 15 minus 5 is 10. And 10 minus 2 is 8. Okay, let's try it, but this time grouping together 5 minus 2. 15 minus 3 is 12. So the associative property did not work with subtraction. So what I want for you to take from this is that all the properties we just learned are regarding multiplication and addition. You are more than welcome to try them out using division and subtraction, but you will find that it does not have the same outcome as addition and multiplication. Okay, that is our lesson for today. A lot of note-taking, a lot of examples. If you did not take notes, I'm going to tell you to back the video up, watch it again, and take notes, because your homework, your practice sets from here on out will have a lot of these examples in them. If you have any questions, you know how to hop on to one of my live streams. Have a wonderful day, and I will see you tomorrow.